3. Properties of electromagnetic waves. The wavelength of microwaves is about several cm, which is close to the physical size of handy apparatus in the school laboratory, which makes it an excellent choice to demonstrate the wave nature of electromagnetic waves. That's why the 3 cm wave apparatus is often used to demonstrate the wave nature of microwaves as a representative of the invisible EM waves. Experiment 6G. Wave phenomena exhibited by microwaves.
We will study different wave phenomena using this set of microwave transmitter and receiver. The receiver is connected to a loudspeaker which sounds when the receiver detects the microwaves emitted by the transmitter. Let's start with the reflection. Set up the apparatus as shown. Move the receiver and see if the loudspeaker sounds. To study refraction, replace the receiver with a point detector. Point the transmitter at the middle of a convex paraffin wax lens. The tips of the point detector should be at the same level as the middle of the lens. Move the detector away from the lens along a straight line. How does the loudness of the sound produced by the loudspeaker change? Now we will study diffraction. Form a slit of about 3 centimeters wide with 2 metal plates. Move the receiver to different positions. Does the loudspeaker sound when the receiver is in the shadow region of the metal plates? Lastly, form a double slit with 3 metal plates to study interference. Move the receiver to different positions. How does the loudness of the sound produced by the loudspeaker change?
Now, there's no question that microwaves is a kind of electromagnetic waves. And for all EM waves, we know that they are all transverse waves that travel at 3 × 10⁸ meter per second in vacuum. And they do not require a medium to travel. They carry energy, the energy that interchange between the varying electric field and magnetic field as the wave travels. This also explains how solar energy from the sun reaches the surface of the earth. Next, they all obey the wave equation, V equals F lambda, and they all may demonstrate the 4 different wave phenomena, namely reflection, refraction, diffraction, and interference. Example 6. Interference of microwaves. In this example, the slit separation of a double slit is 8 cm, which is a few times larger than the wavelength of microwaves, and that ensures an observable interference is to be detected along. In part A, we have to make sure the microwaves can pass through each slit. and so each slit should have a size comparable to the wavelength of the microwaves. In part B, you may find it difficult to explain when the question says there is no loud sound observed when the receiver is placed at P. But look at the transmitter. It is closer to X than to Y. And so, the waves from X and Y are actually not in phase, since the transmitter is not equal distance from the slits X and Y. In part C, the problem in B is fixed, and this question is no longer difficult then. Do chapter 6 on the next page.